This next talk is being presented by Breaking Ground. It's Joining Across the Stack by Eric Kaiser.
Thank you. Welcome to Structured Security Analytics for Cloud Workloads, or Select Star for the Modern Attack Surface. My name is Eric. I'm a security engineer at Uptycs, and today we're going to talk about security analytics. We'll start with a brief agenda, the introduction, which we're in the middle of, some cloud security and visibility challenges, structured telemetry, what it is, why you might care, a brief introduction to osquery, a brief introduction to cloudquery, and an even briefer introduction to kubequery. Then if all goes well, I'll do a quick live demo to show you some of the things that I talk about in this presentation, and there will be a wrap up and time for Q&A. So who am I? My name is Eric. I've spent about 4 years in InfoSec at this point. I'm a relative newcomer. I've had 2 or 3 different career paths at this point. I play defense or blue team. I am endpoint and cloud security engineering internal to Uptycs with an OS and system level security focus. And for my free time, I like to pretend I'm a gearhead by riding and wrenching on motorcycles. So let's talk about some cloud security and observability challenges. From the SANS 2020 CloudSec survey, major issues and concerns related to cloud computing, models, data. The single largest is visibility into and control over sensitive data processed, where that is, how it's managed. But close behind are need for additional IT security staff, seemingly a perennial problem, consistent security controls and policies, and maintaining compliance, another one that everyone loves. Mainly, as we grow, as the cloud grows, as technology explodes, we see an explosion of native services and tools to the cloud, and each of those are separate silos, separate data, separate ways to manage, look at, and introspect things across Amazon, Google, Azure. The challenges are maintaining visibility across the hybrid and public cloud, multi-cloud infrastructure, since each of those providers have different APIs, different ways of thinking about and presenting data. According to 2021 Cloud Pegboard, there are roughly 305 different AWS services, and the curve on that is really only exponential. They count services by namespaces, and we can see the trend of that line. Azure and GCP are unfortunately not much better. They are growing as rapidly, if not more so. And each of those different services are their own silo, their own data, their own piece of wondering about and worrying about, where is this? How is this working? Okay. So the modern attack surface is also exploding, right? Users, applications, and data no longer only live on the corporate network, behind the firewall, behind the VPN, in that safe little walled garden or that crunchy shell with the GUI inside. And observability is really needed across the whole range of cloud-native ecosystems. So in your infrastructure that runs your company's business, or your own personal infrastructure, right? Your workloads tend to be more dynamic, more ephemeral. Resources are spun up and down on demand. DevOps teams are empowered to deploy ever more rapidly, right? 10 or 100 deploys a day. Wouldn't it be nice if security could keep up? If you could have some visibility into that? The traditional endpoints are still there, of course, your hosts, your virtual machines, but they're in some ways at greater risk given the explosion of rolling or flexible work from home policies, pandemics, and new BYOD policies. People really want to work the way that they want to work as opposed to using an IT-issued corporate laptop. Identity and authorization and access management are in some ways the new firewall, right? The new perimeter, especially with zero trust growing as a concept and an idea that wants to be implemented. IAM is in some ways the barrier between malicious actors and the rest of all of your resources. And of course, applications, right? Software as a service. Your sensitive data lives in the cloud somewhere. It lives in Office 365, or it lives in Slack. Ideally, your entire workload doesn't live in Slack or all of your data, but there are some pretty good wikis out there from my understanding. So all of these different pieces are combining to form this new modern attack surface, right? All of these present new risks, new opportunities, but with proper methodology, hopefully they can be observed, if not contained. So structured security analytics is a group of tools that are designed to introspect and identify data in and across all of these different components of the attack surface. osquery is the baseline of this. It starts with hosts, endpoints, virtual machines, and even container visibility. Next is kubequery, which is container orchestration visibility to get you information about your Kubernetes deployments. Cloudquery, which is cloud provider visibility for AWS, GCP, and Azure. And hopefully soon, SaaS query and identity query to be able to pull in and normalize data from your identity providers, your SaaS providers, Office 365, G Suite, Okta, all the usual. So what are, or why, or even structured security analytics, right? So the first and most important benefit is being able to use your security team's existing familiarity with SQL. And on the flip side of that, lessen the impact of unfamiliarity with the vast array of attack surface data sources, right? How you ask questions about an endpoint is completely unlike how you might ask questions of AWS, unless you have a giant logging pipeline and data normalization engine, right? And this allows you to structure queries similarly across heterogeneous OS and cloud platforms. Moving on to the building blocks of this, the osquery is a project that was open sourced by Facebook in 2014. It is a project that was brought on by the Linux Foundation in 2019, just before QueryCon that year, in fact. It supports Mac OS, Linux, and Windows on the endpoint, and FreeBSD if you really needed to. And it was designed for low resource utilization. It has a watchdog, and if it gets out of control, will sort of throttle back and normalize itself, so it's not just one more agent that your users are going to dislike. And the awesome thing that it did was it structured endpoint telemetry as virtual SQL tables for querying. So you could write things like select star from uptime and get an idea of how long the computer had been on, or select star from Chrome extensions, which would allow you to see all of the Chrome extensions across all of the users. And from there, take the Chrome extension IDs and pivot to or join that against reputation databases. Some use cases, right? Endpoint detection and response. Well, detection, osquery's read-only. After the fact, investigation and threat hunting, audit and compliance. On disk, it uses a data cache that is RocksDB, and there's two main components to it. osquery-D is the background daemon that runs scheduled queries. So every 300 seconds or every 600 seconds, get me the list of running processes, get me the Chrome extensions that are on the computer. And the other part, which is osquery-I, which allows you to run real-time and interactive queries. osquery-D is probably the main use of osquery, certainly the main use of osquery as the agent that's running scheduled queries on endpoints every so often. Now, what do you do with those? You have all these wonderful results, all of this wonderful telemetry. What happens? Well, you get to deliver results to various destinations. You can log out to a file. You can log out to a Unix socket if you need. The way that it was originally designed was to take all of those logs and ship them to an upstream TLS endpoint, sort of a fleet manager or aggregator. And that fleet manager in turn could turn around and schedule queries or update query packs across the fleet. Newer extensions to osquery have allowed you to deliver results to Kinesis or Kafka for sort of more traditional cloud logging pipelines as a way to ingest that data as one more piece from your fleet. So, starting with osquery, starting with this idea of a binary that is turning otherwise varied or inaccessible data into normalized SQL and JSON results, is cloudquery. So cloudquery is an open source extension to osquery. It sort of sits alongside it, released in 2021, and it was announced at osquery at Scale. And it extends the idea of SQL-based analytics to cloud infrastructure. Currently, it supports AWS, GCP, and Azure, the three main public clouds, with more tables being added. Right, we started with the bare bones minimum viable product, and more tables and more data sources are being added. And it allows you to, as with osquery-D and osquery-I, run scheduled and real-time queries. Some use cases for that might be resource visualization, right? Being able to ask the question of, show me all of the EC2 instances, show me all of the S3 buckets, show me all of the IAM users. And from there, you can monitor your current configuration, compare that to your baseline expected configuration, so you can monitor drift in your AWS resources over time. Because the queries can be scheduled and because the results can be sent somewhere, saved or logged, you have not only point-in-time data sources or investigational capability, but you also have compliance capability, right? Because you have a record of how things have been ever since you started using cloudquery. So even more than that, right? You can detect misconfigurations, public S3 buckets. You can verify that MFA is enabled for all users. You can do root cause analysis or after the fact security investigations if something has gone wrong. You can again compare sort of previous cloud query results to what might be the case, or even go ask specific questions that you weren't before but can in real time in the moment. Overall security, overall compliance, right? Being able to take all of this data from a cloud and turn that into something that is structured data. We'll talk a little bit more about this as well, but one of the things that you can do is ensure conformance to something like the AWS CIS benchmark, right? Not only as a way to validate not only that DevOps is shipping, not only that security controls are working, but everything is secured to a minimum baseline. So let's take a quick look at how telemetry provides insights using a combination of the AWS Cloud API and osquery running on an EC2 AMI virtual machine in an AWS environment. So let's consider the following sequence of events. Okay. A user who has IAM credentials logs into an AWS account, and they launch an EC2 instance from a trusted AMI in your environment. When that boots, this EC2 instance runs an Ubuntu server, which mounts an S3 bucket containing sensitive data. The Ubuntu software utilities, which are running in the context of the server in the instance, have access to data from the S3 bucket. Okay. Inside that instance, a malicious script launched by the user, whether a malactor or an inside job, as it were, invokes a curl command. That curl command performs a DNS lookup. That DNS lookup is captured by osquery and can be joined against sources that do domain reputation, domain tools, for example. That curl command then establishes the TCP IP socket, and again, that IP address can have a reputation in a database. And then finally, it establishes an HTTPS TLS connection, which can have a JA3 or JARM reputation as well. Once all of that's complete, the curl command exfiltrates the file from the S3 bucket and ships that off. Right? So that scenario outlines the possibilities where a malactor with access to credentials, again, however they came by them, intentional or not, is able to masquerade and exfiltrate information from a cloud workload, right? Sensitive data stored in an S3 bucket, trusted AMI, shipped off data to elsewhere. So the first part of the interactions in the above scenario, which is confined to the AWS API data, this is where cloudquery is going to provide that relevant telemetry. The telemetry includes details about the IAM account used, the EC2 instance details, the configuration and access information about the S3 bucket where the data was stored, and the CloudTrail activity, which captures details about the connection with those specific IAM credentials, launching the EC2 instance from the trusted AMI, and finally, that EC2 run of the Ubuntu operating system. The second part, which is osquery running inside the EC2 instance, has the ability to capture telemetry at various stages of the attack happening inside the virtual machine. So the osquery process events table has the ability to capture that a curl command has been invoked. The process hierarchy in the process events table entry shows the curl command itself with arguments, that the curl command was invoked by a specific user in a specific shell that was created due to an SSH login, and the TTY linked to the SSH login chained all the way back up to the root process manager, PID1. So there's a ancestor of an ancestor of an ancestor of an ancestor all the way back to root. When the socket connection is established, the process socket events table from osquery can provide the necessary information to link the reputation of the IP against a known domain. The DNS events and HTTP events tables provide additional information that can be correlated against the domain and HTTPS reputation databases. The URL information can be joined again against JA3 reputation databases. And additionally, if the file was copied to a disk or a location on disk somewhere before it was exfiltrated, you can use process file events table to capture telemetry to determine if the creation of the file based on folder location or other events might be an indicator of malicious activity. So with all of these pieces, right, beginning from the user logging in with IAM credentials all the way down to the final exfiltration of the file via the curl command, you can see that with these two pieces, there's the ability to track the flow of the attack from start to finish, right, through the entire chain of events. So what can you cloud query? Right, knowing that you can ask questions of AWS, this is a quarter, I think, a third, as an example of the tables that are available in cloudquery that you can ask questions of. EC2 images, EC2 instances, security groups, volumes, all of the IAM groups and policies and roles and users, password policies, S3 buckets, CloudWatch alarms, ECS clusters, EKS clusters. A lot of the data that Amazon exposes, kind of high level or more detailed, is represented across the tables in cloudquery. You can also query GCP, compute disks, images, networks, routes, VPN tunnels, IAM roles and service accounts, just like you can in AWS. Even GCP SQL instances or storage buckets mapped to something like S3 buckets. So let's take a look at a sample AWS CIS benchmark. This is from version 1.2, which is a little old, but still relevant, and relates to securing S3 buckets, right? We want to ensure that S3 buckets are configured with block public access at the bucket level. We want to ensure that all S3 buckets employ encryption at rest, and we want to make sure that the bucket policy allows HTTPS requests. So let's check. This is a sample query for cloudquery. We are getting the name, the status, and the region from the AWS S3 bucket, right? When server-side encryption configuration from the S3 bucket table is not null, then everything's fine. Encryption is configured. When it's not null, then something is wrong, right? When it is null, something is wrong. And then what this does is take that data and present it in a nice table format so you can see at a glance which buckets have it enabled, which buckets have it disabled. There's more to S3 tables than just CIS benchmark compliance or even benchmark compliance period, BCDR or safety, right? Let's make sure that S3 versioning is turned on in case an accidental or malicious employee nukes files in the bucket, right? Not only are the files there, but there is a history of those files, to say nothing of change control, right? You can go back and say, okay, it was changed on this date by this person. This check just ensures that versioning status is turned on. If it's turned on, then great. Otherwise, it pops a warning, right? Something's wrong. Now, that might not be a failure, but this is a great way to, again, see at a glance what's happening with S3 buckets. How about password compliance? We can ensure that the IAM password policy meets all of the requirements, one uppercase letter, one lowercase letter, one hieroglyph, that you were facing west on Tuesday when you made it, that it has a minimum length of 14 or greater, that it expires passwords within 90 days or less, that a black cat walked under a ladder and you saw the full moon in the sky, all the usual. Right? Let's not trust anybody with the wonderful new world of zero trust. Let's make sure not only that users have strong policies, but that the policy itself is configured. So if the minimum password length is set to null, no password policy is set. That is the gateway through which all others must pass, because a policy has to be set. Otherwise, if it's greater than equal or if it's greater than 14 characters, and we have set all of these other things, require lowercase, require uppercase, et cetera, then strong password policies are configured. Otherwise, not at all. This is from the AWS IAM account password policy table, which turns all of the IAM data into, again, a SQL table you can query. We'll talk a little bit more about some of those in the demo when we get to that, and you can see what some of those results look like. So let's talk about kubequery briefly. This is also an open source extension released in 2021, also announced at osquery at scale. Whoops. All right, let's talk about kubequery. This is an open source extension released in 2021, announced at osquery at scale, and it extends that concept of SQL-based analytics to Kubernetes. It has support for Kubernetes, OpenShift, AWS EKS, and Google Cloud GKE. It doesn't currently support Azure Kubernetes, but I believe that is in development. Okay. So the use cases there are container security at the individual and pod level, right? Monitoring configuration and security policies, and again, everyone's favorite, compliance. It is important to be aware that kubequery runs as a daemon set in Kubernetes. It doesn't run in each individual container. That's the role for osquery in each container if desired. There's a lot of prior art about osquery in temporary containers being spun up and spun down. It is still possible to get useful data out of them. QueryCon 2019 is a good starting point for that if you want to dig further. It's also important to be aware that the amount of JSON in SQL columns that comes back from Kubernetes can be quite high. It is normalized. A lot of it is turned into individual columns in the tables, but because there is a great deal of flexibility in the data that comes back, some flexibility has been left in on purpose, and that's where SQLite or other SQL engines JSON parsing can come in to turn that into columns or other data as you see the need or see fit. So there's a missing piece in all of this, which is that you will probably want something upstream of all of these different osquery extensions that are running in the cloud, as a daemon said, in Kubernetes, on an EC2 AWS instance, running queries every so often. And that is query TLS. So it is a very, very, very minimal osquery upstream TLS endpoint that can be deployed in AWS as a Lambda function. It persists log data to S3 organized by day. It allows you to create rule and alert notifications using JSON logic, and it is a very minimal bare bones logging infrastructure for cloud and kubequery and osquery to get you started seeing what scheduled queries from kubequery D and cloudquery D are going to look like. All right, it's demo time. So we talked a little bit earlier about the AWS S3 bucket queries. I've got a live demo environment running cloudquery. Let's go ahead and switch over to that and see what the queries look like. So again, I'm running cloudquery in a Docker image. It is a bundle, which is how cloudquery is shipped. It's the easiest way to get started. You can run it in an EC2 instance with cloud permissions, or ideally a credentials.json file for an AWS service account. We're running osquery I to do cloudquery queries. Again, these are things that would normally be expected to be run as scheduled query packs by cloudquery D in the background somewhere, checking on the status of these things from time to time and then shipping those logs somewhere else. So it can take some time to return data, which is especially why running those scheduled queries is helpful, but we did get a quick result back here from the AWS IAM account password policy. And for the purposes of this demo, you can see that we do not have strong password policies. They are not configured. So again, we do have a minimum password length set because it's not null. So we didn't get the no password policy set warning. But while the minimum password length is less than 14, so again, for the purposes of this demo, this is not a good AWS security policy. Let's do a quick recap. So cloudquery extends osquery to deliver data about cloud infrastructure in a structured format. Right? It's taking all of the pieces of AWS, the pieces of GCP, the pieces of your infrastructure in Azure, and it's turning all of that into a set of SQL tables that you can ask questions of, generally in real time, especially, again, for investigative purposes. kubequery does the same thing for public cloud Kubernetes, right? Being able to take all of the data across all of these various different sources and stream that data as JSON results to your upstream aggregator, whether that's query TLS, whether that's Kinesis or Kafka, whatever your upstream logging or investigation or normalization solution is, you can take all of this data and ship it there. You can also, if you're using some kind of TLS endpoint or interactive osquery, turn around and ask questions of all of these different data sources across your fleet, right? Again, we talked about some of the use cases there: cloud security investigation and threat hunting, audit and compliance, especially with the history of your results over time. IT or operations, configuration, and monitoring. Again, telemetry-powered security or structured security analytics, the various different adjuncts and extensions to osquery, the tool suite consisting of osquery, which is for your hosts, virtual machines, endpoints, visibility inside containers, kubequery for your container orchestration visibility, and cloudquery for your cloud provider visibility. Ideally, SaaS query and identity query are coming soon. They are things that are being worked on to round out your ability to ask questions of all of these various data sources. Where do you get it? I'm going to leave this up here for just a second. github.com/upticks and cloudquery, kubequery, and query TLS. Again, cloudquery and kubequery are cloudquery is distributed as a Docker image. kubequery is a Kubernetes daemon set that you can deploy, and query TLS is an AWS Lambda function that you can use as your upstream result aggregator. And now, with the plethora of remaining time that I'm sure that I have, I am happy to take and answer questions.
All right, great. Thank you so much for that great presentation. I really appreciate it. I've asked a couple of people this question as we've gone through. People submit these talks, weeks, months before the conference happens. Are there any updates you'd like to give before I start going to the chat for questions?
A couple of pieces, and thank you so much. I did not manage to get the demo working, but I will drop the actual queries that I used in the chat so folks can take a look at those if they want to go play around with them to get a sense for those AWS S3 queries. And I will do that in just a second. The other thing that I will say is that because this project is fairly new, it was released right at the beginning of 2021. It's 6 or 7 months old. It is growing fairly rapidly. We're adding new tables and new data sources pretty often, even from like when I went from planning this talk to going through and the CFP and all of that. I think we've almost doubled the amount of tables across all 3 major data sources. Wow. It's certainly growing, and we're trying to keep the momentum going, keep putting it out there.
Obviously you're up here giving this presentation, but it sounds to me like there's a lot of people behind the scenes behind the talk here. Do you want to talk about that for a bit?
Yeah, I surely do, and I definitely don't want to take a whole lot of credit for this. I am blue team at Upticks, and I use this tool every day, but most of the coding and all of the sort of behind the scenes work was actually done by a whole crew of talented individuals over here. And I want to give a big shout out to them and a thank you, because this kind of work wouldn't be possible. I'm just sort of the face of the project, at least in this particular talk. So for sure. The other thing that I would say, maybe as a piece of that, kind of why we did this and where that came from is Upticks is an osquery company. We started with osquery specifically for just the endpoints. And as we've grown and as we've seen needs grow, we've sort of started using and developing tools to build on that. Because of the power that we've seen in structured telemetry. And again, I mentioned some of those in the talk. The 2 that are hypothetical are still hypothetical. I don't have anything else to add on that, but we are still interested and looking forward to doing those at some point.
Great. All right. I've been doing these interviews now for the last 2 days, and one of the things I like to ask first, it's always interesting to me for researchers, what was the hardest part about doing this research for you?
So the hardest part is actually what the project was intended to solve, especially for cloudquery. Working with 3 different public cloud APIs, how those calls are made, how being able to talk is, 3 different languages, right? 3 different full APIs across however like 600 different individual services, and taking all of those results, taking all of those requests, and turning that into something that looks like a SQL table or a SQL database that you can actually access with those queries. There's a lot of JSON. There's a lot of other things that come back, and normalizing that is hard, and it's still hard. There are, we're continuing to work on it, but there are times when you'll get a table row or a column result that's entirely JSON, because there isn't necessarily a clean way to parse that out into something that maps cleanly to just columns and rows. But we like to think we're making progress.
Right. Yeah, it sounds very complicated to be dealing with that many data sources. So in the same vein, so then what, there's hard pieces, but what was surprising about this research?
Both some of the ways, I guess what I'll say is the surprising part about was like how cool it was when it came together. I'm not used to thinking in SQL. I came to that sort of late. I was a lot more like Elasticsearch, sort of unstructured data, and just figuring out how to work through that in incident response or other kinds of things. But being able to look at it in database form and being able to kind of join both from cloud sources and endpoints, and being able to watch an attack move from somebody in San Francisco and someone else who's awake across the world, and through that the cloud, being able to see all of those pieces connect using a single tool was very powerful. That was one of my like aha or ooh or very cool moments.
So why do you think no one's done this before? Or have they tried and failed, or like?
So there are actually a couple of other things like this. I don't know that we can claim that we're the first necessarily, though we are definitely trying to do our best. SteamPipe is another option out there that does sort of similar ideas. I don't actually know if that's open source or not, but it's been come across my radar recently. And there is actually something else called cloudquery that does things very differently under the hood. That's a Neo4j database and graphs and all of the rest. And that is like cloud first and cloud only. And we started at the endpoint and are working our way up kind of through all of the various different pieces of the stack. So it's just kind of a different directional approach.
Nice.
The other...
Okay.
Apologies not for cutting you off, but the thing here is being able to take. We've had a lot of. I've heard across all of the osquery conferences that I've been at, and some of the blue team hangouts is. osquery, a lot of folks love osquery. It's open source. It's awesome. It's a great endpoint monitoring agent. And it is now old enough that there is a great deal of experience, or at least, 5 or 6 or 8 years of experience with osquery, and people want to take that. They want to take the experience that they have. They want to have take the people on their teams who know how to work with it and are sort of thinking that way, and move that into other areas of the attack surface in the company.
Yeah, so speaking of enterprises, we were talking previously about how I'm from the Bay Area, and a lot of those companies were cloud native. They grew up in the cloud.
Yeah.
But other legacy companies are slowly moving their infrastructure to the cloud. Do you think this gives them, a leg up in terms of being able to monitor both the endpoints and the cloud stuff in one space? Is it going to help them centralize faster than say the companies that had to build this stuff from scratch?
I'd like to think so. So the first piece of that is there are certainly a lot of folks in your enterprise who have SQL experience, right? And being able to take that and how you think about getting data out of databases and being able to synthesize and correlate that together, being able to just take that and apply it in a new domain by virtue of this tool is very powerful. And we like to think that the on-ramp is pretty short for that. It does again, because of the sort of direction that we're building this from workstations up, starting with osquery and being able to look at your fleet, and that's servers and laptops and workstations. Like, if it runs an operating system, you can put osquery on it, and then being able to do the same thing with the cloud, right? It's one tool for all of the things that you care about, right? Being
Right.
able to, instead of this tool for endpoints and this tool for the cloud, and wait, that was the wrong tool, and we have to go back and do it, and we, now we have 2.5 tools because we're behind. Start with one, grow from there, right?
Mhm. Nice. Yeah. So, this project is an open source project. And we talked about earlier how, this is not the first, but it's the first way of doing this. When it comes to the blue team and sort of centralizing and normalizing this how mature do you think the open source community is when it comes to stuff like this?
So I would call this sort of late early stage, right?
Right.
There's osquery is fairly mature. This project is 6 months old. I'm not gonna, and it's a little bit older than that internally. It is one of the underpinnings of the service that Uptycs offers. It powers parts of our stack, but there's certainly work to be done to figure out how to not only add new data sources, again, just in general, right? Like figuring out how to take data from various different clouds, put that into database form. There's plenty of opportunity, and we welcome contributions. We'd love to see, what can be done with this in ways that we haven't even considered yet. So it's stable, but still early days.
So what do you see the future? Like what gets you excited about the future of this?
So the excitement for me is adding data sources that aren't necessarily traditionally thought of as the cloud. So maybe a good example I can give is Terraform. Right, Terraform's an infrastructure as code tool, and you can use Terraform. When it started, it was, use it for AWS, use it for spinning up resources in the cloud, spin it up for GCP. And Terraform has turned into being able to, plan out your entire infrastructure across all kinds of different things. Cloudflare, for example, you can spin up, whole different pieces of Cloudflare infrastructure in Terraform, even though it wasn't necessarily created for that. And so I would love to see this sort of structured analytics approach go from just not just this piece of the cloud or how we traditionally think about the cloud, but all of the resources that you might have in the cloud. Again, SaaS, identity, various other resources, being able to pull that all into one bucket, or at least one sort of structured kind of bucket, and query that no matter the data source.
So you gave a great presentation, and we've been talking for 10, 12 minutes about this. What people want to get really get into this. What would be the three key takeaways from this? What would be the most important thing that they take away from this talk?
Yeah, so the things that I'm excited about, the things that I'd love for people to keep in mind is not only that osquery is out there, because it is awesome, and maybe for folks who haven't considered it, please do check it out, but now it can do even more. By virtue of these open source extensions, you can go query your Kubernetes infrastructure on public clouds, get data the same way. You can query your AWS, Azure, and GCP resources the same way. And check out our public GitHub repos, github.com/Uptycs. The links are in the slides. I'll put them in the chat again if people want to check them out. And pull requests welcome.
Okay, that was going to be my next question: is where can people follow up and follow the research? But do you have a Twitter handle or anything that you want to put out there for people to follow?
I do exist on Twitter, but I can't say that I post about this much. I'm not as active as I would like to be. GitHub's the place to go.
All right. Well, great. Well, thank you so much for giving this presentation. The Breaking Grounds is for new and exciting research, not just red team, but also blue team. So we really appreciate you submitting the talk and coming and taking the time to give this talk. So thank you so much.
Thank you so very much for having me. It's been a pleasure.